You know, it's an unfortunate thing that so many students have a bad taste in their mouth when it comes to learning mathematics. You know, the problem is with a lot of math teachers, they throw at you all of these formulas and all of these rules, and they expect you to learn it and to do it. But what they don't show you is the practical life application behind a lot of these mathematical equations. The beauty of chemistry is you get to do some math, but you see its consequences immediately. You know why it's useful, and you know why you're doing it. And that makes the math behind it a whole lot easier to understand. What would be cool is to one day be able to teach a math class just using science, because you could do it. It would take some time and some thought, but it would be worth it. I say all of that to say this: math is the language of chemistry. And throughout chemistry class, or really any science class that you take, you will discover the need to solve basic algebraic equations. So here are a few examples. In the second semester of this class, we'll learn about solutions, and we'll learn specifically about a concept called serial dilution. So think about it. Say that you've got, Clorox bleach, right? And it's a little bit too strong for whatever you need it for. And so you might pour some out in a cup or a container. Then you might add some water to it to make it weaker. Well, that's called dilution. And there's an equation out there that tells you how much water you need to add to a certain amount of Clorox bleach to water it down by a certain amount, right? Instead of you just having to guess by dunking some water in there, right? So the dilution equation, essentially what this says is the concentration of a chemical times the volume of it, so how much you have, is equal to the concentration of the diluted chemical times the amount of volume of the diluted chemical that you have. And in my class, I'll give you 3 out of these 4 variables, and I'll ask you to solve for the 4th. So let's go ahead and just, play with this a little bit and see what we get. So again, this here is the original chemical. And this is actually called the stock solution. And then over here, you have the diluted chemical. And that's after you add water. So what if I told you that M1 maybe was equal to 3? And V1 was equal to 4. So that means you have a original chemical that had a concentration of 3 molar. You don't know what that means, but you will later. And you have a volume of 4. We'll just make it 4 liters. It doesn't matter at this point. The concentration of the more diluted chemical, so you've added water, say, goes down from 3 to 2, and you have a volume, maybe a 5. I'm just making numbers up. It really doesn't matter. Well, you know what? I shouldn't have given you this number right here. Let's take that away. And so my question to you is, I've given you 3 out of the 4 variables. Can you solve for the other variable? All right, so let's just plug it in. The equation's M1 V1 equals M2 V2. So for M1, we said it was 3. Times whatever V1 is, that's 4. It equals M2, which is 2. And we're looking for V2. We don't know what that is. So I'm going to go ahead and write that down as V2. So the question is, how do we solve this mathematical equation? Well, you have to think about the variable you want to get all by itself. And we want to figure out what V2 is. So that means we have to get rid of everything else. So the way that we get V2 all by itself is to simply divide each side by the number 2, right? And so if we divide each side by the number 2, it's going to look like this. All right? So we're going to have 3 times 4 divided by 2 is going to equal V2. So let's think about what that is. 3 times 4 is what? it is 12, and 12 divided by 2 is 6. So that means that V2 is equal to 6. And that's how you would solve this equation here. So that's what a dilution looks like. Let's go ahead and move to another example, another type of mathematical equation you might be expected to solve in my class. The quantization of energy. Energy is equal to Planck's constant times the frequency, or E equals h nu. Again, you don't know what that means right now, but you will. But really what I'm more concerned about is that you know how to solve this equation, right? So what if I told you that what if I gave you the value of energy? I'm just going to make up random numbers. So the energy was 5 joules, which joules is a unit, not something you know, vapor or whatever. So that I told you Planck's constant, well actually Planck's constant is always 6.626 times 10 to the negative 34. You'll learn why later. And what if I ask you what the frequency was? All right, so you would just plug it in. E is 5. It's equal to Planck's constant, h, which is 6.626 times 10 to the negative 34, and times the frequency, which really should be nu and not just a v, but it's a whole lot easier to type v. So how would you solve for that? Well, you want to get v, the frequency, all by itself. The way you do that is you divide by whatever's in the way, and that's 6.626 times 10 to the negative 34. Problem is, what you do to one side, you have to do to the other. Very good. So 6.626 times 10 to the negative 34. We're going to rewrite this. So we have 5 divided by 6.626 times 10 to the negative 34, and we've isolated v. And whatever that is your answer. All right? So this is an energy equation. It has to do with these cool particles called photons, and we study those in the second unit in my class. We're dealing with energy and electrons moving around in color, and it's just pretty cool stuff. Oh, the ideal gas law, right? So here's the deal. P is pressure. We have a general sense of what pressure is, whether it be tire pressure or air pressure. V is volume. That's the same thing as you saw in the V1 and the V2 in the dilution equation, right? N represents essentially the amount of gas that you have. R is a constant. You're going to be given that number. And T is temperature, right? So, and I know that, you know, for those of you that are a little bit advanced, yes, there are specific units for temperature, and R depends on certain things, but I'm just going to give you some random numbers, and we're going to see if we can solve this, okay? So what if I told you that the pressure was equal to 2? What if I told you that the volume was not given? N is equal to 1. R, let's do this. R is equal to 4. And T is equal to 2 also. Let's plug these numbers in. So P, we said, was equal to 2 times V, which we're solving for, we don't know what that is equal to, we said N was 1, we said R was 4, and we said T is 2. Now again, look, this is just to show you how to rearrange a mathematical equation in chemistry, okay? I know, you know, I know some of these values are off, but it is what it is. So we're solving for volume. How do we get volume by itself? Well, there's only one thing in the way from keeping volume from being the only thing on the left-hand side of the equation, and that's this 2. So we're doing a multiplication function here. Let's go ahead and divide by it to undo it. So we're going to divide each side by 2. That cancels it out. Divide each side by 2. So here's what it looks like. V is equal to 1 times 4 times 2, all divided by 2. That's going to cancel. That means V, the volume, is simply equal to 4. Right? And so that is the basic math that you're going to be doing in chemistry class. It is so important that you're able to rearrange equations to be able to solve for specific variables. And remember what I told you earlier, that math is the language of chemistry, okay? We're going to do a bunch of practice problems like this in class, and I'll help you as much as you need. And thank you very much.